Right. So in our previous class, we did a small lab in which we did eBGP and IBGP configuration. We had similar topology and we formed an IBGP between two routers using loopbacks. I hope you remember, right? We used loopback to form
Yes,
neighbor
we used
between
to
these two.
that in the routers, and then that when we tried to ping that loop back.
Yeah, after that we used update source command. Do you remember that?
Yes, sir, update source command.
Yeah, we don't have that command here because this example they don't use loopback. They use physical interface IP address, so there is no need to say update source. The default exit interface becomes the source, which is mentioned here as the neighbor. I repeat, this is something very important what I'm saying. When B is sending traffic out, what will be the source of the packet? Source address of the packet? The exit interface address, correct?
Yes, sir.
B only sends. So B's exit interface is 10.2.2.2. That source address should match with the neighbor statement. Is it matching?
It is matching.
Yeah. That is what mentioned in this page. See, if match is found, the relationship is established. If match not found, then the packet is ignored. When we are forming neighbor with loopback, the match will not be found because the exit interface is not mentioned. The exit interface address is not mentioned as the neighbor address in the neighbor statement. So the match won't be there. I repeat. You see, when you form neighbor with loopback, when I say my neighbor is 1.1.1.1, I'm saying my neighbor is 1.1.1.1. But the traffic is coming from where? 10.2.2.2. Correct? No? By default.
Yes.
By default, exit interface address becomes the source. Is that source matching here?
It is matching.
Hello?
Hello, sir.
Is that source address matching here? I said that.
10.2.2 is the source address.
Yeah, but here I have written neighbor as 1.1.1.1 and
It's not
router.
matching, sir. It is not matching.
Why it is not matching? Because by default, exit interface is used as the source.
This interface.
But here I have mentioned neighbor's loopback interface address, so it is not matching. So what we have to do is, we need to tell this router, whenever you speak to the neighbor A, you need to use update source loopback. So this interface will be used, then there is a match. That is what I mentioned here. You see, when creating a BGP packet, the neighbor statement defines the destination IP address and the outbound interface defines the source address. Do you understand this?
Yes, sir.
What did you understand?
So when the neighbor source IP address is different, it's not matching.
No. I'm not asking that story. I'm asking about this first paragraph. I repeat. When creating a BGP packet, now a router is creating a BGP packet. For that packet, two addresses are needed. One is source address.
Okay.
Another one is destination address. Now, from where you learn the destination? How you know the destination? How BGP knows the destination? The BGP knows the destination from this address that you mentioned in neighbor. Correct?
Yes.
You are telling that this guy is the neighbor. So that address will be taken as the destination. That is what mentioned here. You see here. The neighbor statement defines the destination IP. Did you understand this statement now?
Yes, sir.
And then the outbound interface defines the source. This is default. Okay. By default, what is the source address? The address on the egress interface. Outbound interface, not the loopback. By default. By default, is loopback address source address? I'm asking question. By
No,
default,
no, sir.
is loopback address source address? No.
No, no.
The outbound interface is only source address.
Hmm.
Okay. Now let us read the next line, next paragraph. When a BGP packet is received, now this is on the receiving side. A router is receiving for a new BGP session. The source address is compared with the list of neighbor statement. So when a packet is coming from the neighbor, the source address will be matching, will be compared with the neighbor statement which is configured locally. If match is found, relationship is established. If match is not found, the packet will be ignored. I hope you understood this now.
Exactly.
So what we have to do to match, we need to make sure the source IP address matches the
Neighbor.
address that the other router has in its neighbor statement. So we need to somehow make it match. How do we make it match? Tell me. What is the command that we use if we want to match loopback
Update.
interface? Ah, very correct. That's what the next 3 pages going to explain you. 3 pages you already learnt. But before we go to that, now try to answer this question. Go through this topology and try to answer this question. Take a minute, please. What will be the address we will be using to form neighbor? It is 4.4.4.4 and 1.1.1.1. See, between router A and D, to form neighbor, you can also form neighbor with a physical interface address 10.2.2.4 and 10.4.4.4. But the problem is, if this link goes down, the neighborship will go down. Then you need to form another neighbor with this 10.4.4.4 also. To avoid that, whenever we got redundant path, we will form neighbor with the loopback. So even if one of the path exists, I will have neighbor.
Neighbor.
If any one path is available, my neighbor will be there. So high redundancy, availability is there. High availability is there. When you form neighbor using loopback, you have high available. Yeah?
Yes.
High availability. If B goes down also, we don't care. Router C is there to take you to 4.4.4.4. Yeah? So wherever we have multiple paths in an enterprises environment, in an enterprises environment, we used to have what? Redundant paths. Whenever you have redundant paths, what do? We form neighbor using loopback. Okay. Now to define the neighbor, we used to use this neighbor statement command, which you already know. But we use here update source. That's one keyword that you are additionally using. Neighbor IP address, and then update source loopback 0. Yeah, that's how we type. So that changes the source address so that it can match with the neighbor's neighbor statement. Like this. We already did this lab.
Yes.
Now you see, between B and C you have 2 paths. When you have 2 paths, it is good to use loopback to form neighbor. That's why we say neighbor is 33333. We are not saying 10.1.1.2. We are saying 33333.
Loopback IP address of C.
Likewise, we go to C and give the loopback IP address of B. And then we say update source loopback 0 so that C will use its loopback 0 address while talking. B will use loopback address of B while talking to C. To provide reachability between the loopbacks, we have EIGRP running. See, they need reachability because it's TCP based protocol, isn't it? Right. Now, between EBGP, if you wish to form neighbor using loopback, what you need to do? Remember, we learned something like main difference between EBGP and IBGP. The main difference is what? EBGP need to be directly
connected.
connected.
EBGP will be directly connected, and IBGP can
Need not to be connected directly. So EBGP need to be directly connected. Now, if you are trying to form neighbor between EBGP routers using loopback, if you are trying to form neighbor between EBGP routers using loopback, are they connected directly? No, they are not. Then what should we do? We need to break that rule. But you need to break the rule by confirming security. Listen, the reason why EBGP need to be directly connected is you are forming neighbor with someone not a member of your own autonomous system. They belong to different autonomous system. So you are trying to form neighbor with someone in public, isn't it? That's what EBGP. What do you say? Is EBGP forming neighbor with your own people or different people? Different. That is why you want to have neighbor as a directly connected. That's why BGP is designed to form neighbor with the directly connected. Okay, so they need to be directly connected. EBGP neighbor need to be directly connected. The reason why it is designed like that is so that they will have that guarantee that it is secured. For security reason only EBGP neighbor need to be directly connected. Now, if you are saying I will form neighbor using loopback, you need to break that security. But if you are breaking the security, make sure that you are still safe. You need to make sure that even though you break the security, there is no violation, there is no unwanted neighborship, there is no wrong neighborship. How do we achieve that? By giving this one of the command. If you say EBGP multi-hop, you're telling EBGP multi-hop to what does that mean? It means that neighbor need not to be directly connected. EBGP neighbor can be 2 hop away. This is the command that breaks the rule that neighbor need to be directly connected. When you say EBGP multi-hop 2, even when the neighbor is not directly connected, in less than 2 hop, if neighbor is there, neighborship comes up. So forming neighbor between loopback to loopback becomes possible. It becomes possible.
Yes, sir.
There is another command equivalent to that is this TTL security hop 2. You can use any one of this. I recommend this more than the first one. Many people know the first one, but not this one. This is more secure than the above one. The above one will focus on the outgoing TTL. The inner one, the second one, focuses on the incoming TTL. Use any one of this command to form EBGP between routers that are in different autonomous system using loopbacks. Okay. So let's see one example here. You see A and B are not in same autonomous system. They are not. And they have two EBGP neighbor. Sorry, two EBGP connection, two WAN connection or two connection between EBGP routers. So what is written here is two static route. Because you got two connection, no? You see 1.18, 1.34. On router A we say to reach 1111 you can go to 1.18 or 1.34. Likewise on this router we say to go to 2222 you can go to 1.17 or 1.133. Do you understand the static route?
Yes, sir.
Once the route is there between the loopbacks, the usual commands, neighbor command, see this is EBGP neighbor 02, this is 01, and you see update source loopback 0 to change the source address, EBGP multi-hop command to break the rule that says need to be directly connected. So it will start sending the traffic with the outgoing TTL of 2. So the traffic, the negotiation goes to the loopback and the form neighbor. Is this clear?
Yes, sir.
So forming neighbor between two routers that are not in same autonomous system needs this additional command EBGP multi-hop. As usual, you should say update source loopback 0 command. Additionally, you need to say this one to break the rule which says need to be directly connected. The command is EBGP multi-hop 2. Or there's another command more secure than this is TTL security hop. The second command. Yeah?
Yes.
Second command you can use. So I'm going to demonstrate this. Are you ready?
Yes, sir.
Right on router 2, let me put the IP address interface loopback 0 IP address 2.2.2.2, and then I would like to give another address on the physical interface. The interface name is F00. .200.12.0.2 0. Next is, let us write a static route to reach loopback interface address of R1. That's very important, right? If there is no reachability, then conversation won't happen. So IP route, this is the network on router 1, and I want to send the traffic to 200.12.0.1. Now, let us go to router 1 and finish this basic configuration first. I'm on router 1. Done. So what is next is static route. IP route 2.2.2.2, send the traffic to 200.12.0.2. Okay, so what we need to do is, before we start configuring BGP, we need to make sure that we are able to ping the neighbor using our loopback. So I ping from here 2.2.2.2 with the source. I'm able to ping. Then it's ready. That's the meaning. It is ready now for our BGP configuration. As of now, we don't have any BGP. Show IP BGP. BGP is not active. I'm going to say router BGP 1000. And I got a neighbor. It is not 200.12.0.2. It is what it is. Correct. 2.2.2.2. Remote AS
2000.
Correct. 2000. But the problem is this one 2.2.2.2, if you check the routing table, it is not directly connected. Does it say directly connected 2.2.2.2?
No. Via.
Ah. See, 200 is directly connected, but 2.2.2.2 is not directly connected. So this won't even send any packet out. This router won't send any packet out. I can prove you that by capturing in the Wireshark. You won't see any BGP packet, any TCP packet coming in between. No TCP packets, no BGP packets will come to negotiate with the other guy. So meanwhile, we'll go to router 2 also and say router BGP 2000. Neighbor is 1.1.1.1. Remote AS is, oh, I made a mistake. What is the mistake? What is the mistake? I made a mistake. You can see that right on the screen. What is the mistake I have done?
2000 is the one.
So if I try giving 2000 now, it won't accept. Only one BGP in the router. It won't accept. So I have to first remove the 200. No router BGP 200. Now router BGP 2000. Neighbor 1.1.1.1. Remote AS 1000. And then neighbor. Okay, now what I'm trying to say is both the side we have configured, but there is no packets related to BGP is coming in Wireshark. The reason is that directly connected is expected by default. You don't have directly connected in the routing table. For this network, if you check show IP route, there is no directly connected. It says it is via. It says it is via this gateway. Show IP route. It is not saying directly connected. It says via. So to break this rule, what do we need to do? Router BGP 2000. We need to say. So neighbor 1.1.1.1 and we say update source loopback 0. Now will this command solve the problem? Not really. This is simply changing the source, but what will solve the problem is eBGP multi-hop 2. So similarly, we have to do here. Router BGP 1000. Neighbor is this guy. Update source loopback 0. eBGP multi-hop 2. Now we will see neighbor coming. It will come. We need to give some time. Yeah, the neighbor has come up. You can even see in the Wireshark lot of TCP and BGP packets. And if you see here, the first thing that happens is the three-way handshake. You see that? SYN, SYNAC and ACK. And then open message. And then keep alive message. And then update message. A notification message will come only if there is an error. There is no error, so no notification has come. These are the message types we have in BGP. Open message, keep alive message, update message and notification message. Alright, so we have formed a neighbor. Let's verify here. Show IP BGP summary. You can see the neighbor is up for last 50 seconds. The local AS number is 1000. The neighbor's AS is 2000. This makes this router to realize that this is an eBGP neighbor. Right? Fine. Now, what is next? let's go back to our presentation. You can also use this TTL security hop command instead of EBGP multi-hop command. Now what is the difference? Now I used EBGP multi-hop, right? I used EBGP multi-hop.
Yes, sir.
That will impact the outgoing TTL. Let me show you that. Show IP BGP neighbor. If you see here, the outgoing TTL is 2 because I said EBGP multi-hop 2.
2.
But when I say TTL security, it will impact the incoming TTL. Here the TTL will become 255 minus 2, which is 253. If I use the TTL security command. Let us go and do that. I'm going to remove that EBGP multi-hop command on both the routers. And then let's refresh. Clear IP BGP start. This is to refresh. That's all. The neighbor will go down and it won't come up. The neighbor is gone down. Show IP BGP summary. See, the neighbor is idle. Do you see the word idle there?
Yes.
It is idle. The neighbor won't come up unless we fix that issue. So I'm going to this time use the TTL security command instead of EBGP multi-hop command. I say router BGP 2000 neighbor 1.1.1.1 TTL security hop 2.
Okay.
EBGP multi-hop is not used now. TTL security. Likewise, I'll go here and say neighbor 2.2.2.2 TTL security hop 2. Now also neighbor will come up. See, the neighbor has come up. See on the Wireshark again, if you go down, you see again the three-way handshake has happened, and again the open message, everything is sent. Now, let us check the difference. Show IP BGP neighbor. This will impact the incoming TTL. See, outgoing TTL is 255, but the incoming TTL is 255 minus 2, which is 253.
Yes.
Yeah, so this is more secured than that. How this is more secured? Our router will accept the neighbor if it is 254 or 255. It won't accept if it is 252. If it is 252, it is coming from more than 2 hops, so it won't accept. See, for every hop, the TTL will decrement. The sender will send with 255. The next router will decrement and send as 254. The following router will send by 253. So,
That is next.
yeah, if a router is more than 2 hop, it cannot form neighbor. It's more secured here. That's why the command itself is security, TTL security. Yeah, the secured way. You understood this?
Yes, sir.
Okay. Alright, the next up behavior.